Hello, everyone, and welcome to the first of our training webinar series. This is Danielle Sandal, and I'm here with Kate Fontanella, who's a technical trainer here at Vertica, and Ron Cormier here to help answer questions. He's a professional services consultant. So, as I mentioned, this is the first of three, and we'll start at the same time tomorrow and again on Thursday. Each session will run about an hour, and I'll hand you off to Kate to get it started.
Hi, everyone, and welcome to our first webinar in the series. Again, my name is Kate Fontanella. I'm one of the trainers here at Vertica. And what we're really going to talk about today, is the first in this series is we're going to talk about some of the system enhancements. And I'll let you know that this particular webinar, we're going to have a lot of different topics covered. So as we go along, there is a question section. So if you do have some questions specifically on specific topics, feel free to put those in. If we get a series of questions as we're going along, we may stop and answer some of those as we go along, because some of these topics aren't necessarily directly related to each other, but they are all some of the 7.0 system enhancements. So that's really what we're going to go through today. And specifically what we're going to look at are some of the installation improvements. And for those of you that are planning on upgrading to 7.0, some of these are really going to affect you as well. There's some better checks that are going on with the system, and with the upgrade, you're going to see that will affect you. So we want to make sure that you know that those are out there. Then we're going to look at some load improvements, including some of the changes in the copy command, spread, as well as the introduction to fault groups. So we're going to talk about how those are set up and how they can affect larger clusters, customers with larger clusters. We're also then going to look at the SQL Server improvements, and then we're going to finish the hour up with some enhancements that are going to help your queries run faster. So we're going to look at some of the query optimizer enhancements, as well as some of the new tools that are out there. So first of all, during the installation of HP Vertica, it's going to start to attempt to set various OS level parameters. So if the installation script failed to set key parameters, you may see warning messages similar to the one that you see on the screen here. And the thing that you want to remember is that there's stronger checking of the pre-installation and the upgrade setup. So even if you've installed Vertica in the past, but now you're upgrading, you might start seeing some of these failures. Now, the nice thing about some of these failures is that you're going to be able to see that right over here, there's actually a link to the docs. So if you get one of these hints, it's actually going to link you directly to the docs. You can go in, you can look at what specifically is the issue, and maybe look at what might be wrong with your setup. So for those of you that are installing for the first time, you may see these, but even for those of you that have Vertica installed in previous versions, as you're upgrading, you may see these. So you do want to be aware of them, but the nice thing is it's much easier to handle. The other thing you're going to see during the installation and the upgrade process is some improved on-screen output. So you'll see that things are going to be colored so you can kind of read them more carefully. This is just one example. This is a successful hint and notation. There will be others, but it will be easier to read. So that's really the point of this, is that it's going to do some better checking to give you and give you some hints about your setup, but also it's going to give you some really good information during the installation or upgrade process that you can look at. The other thing that's going to happen with the installation is we do have some more useful and consistent installation log files, and you can find it at the Ops Vertica log admin tool -root log files. And then the other improvement is really the long form commands. And we want to point this out that's out there. A lot of you, especially if you've been working with Vertica in the past, you've been using probably the short form command. So, for example, using -s instead of --host. This isn't really a big deal in terms of how you do things. If you know the short commands, it may be easier. But for those that are first coming into Vertica, being able to see that -s really just is talking about the host is a little bit easier to understand. And so there are more long form commands, And these are written up in the docs, and you should definitely take a look at them as you're going through this. So these are just some of the new improvements. The other thing that we want to talk about a little bit is spread. Now, spread is the tool that Vertica uses to communicate across the node. So before Vertica 7.0, spread had a maximum limit of 120 nodes. Now, of course, we've had customers that have more than 120 nodes, but they had to do a lot of different things to get that moving along. But with this upgrade, spread can accommodate larger clusters. So systems with more than 120 nodes by sharing spread among multiple nodes. And we're going to get into this a little bit in the next topic, but just understand that it's able to manage a larger cluster now. Smaller clusters can also benefit from this, from using shared spread if you wanted to span your spread across multiple racks. And again, we're going to get into this when we talk about fault groups shortly. To get this to work, you would use the command ninstall Vertica --large cluster n to indicate how many nodes should contain spread. So right here in this command here, the n is actually going to represent the number of nodes that you would set up. So Vertica will create n-spread nodes, and then the non-spread nodes share spread with the n-spread nodes. And the idea is that the non-spread nodes don't have spread. So they're sharing it with where the n-spread nodes are located. You can also use the large cluster configuration status system table so that you can observe the control node and the current spread host for each node. So the large cluster configuration status system table will allow you to see what's going in will allow you to monitor where your spread is located. Okay. Another fundamental difference with spread is that it's now managed at the start and stop time. This is different than previous versions where spread was started at the installation. This is going to help solve some of the large cluster systems. Some of our large cluster customers did have some issues with spread. So now that it's starting at the start and stop time, it's going to work a little bit better. And finally, spread now uses the node tables rather than vSpread comps to get its information about the nodes. So users that are going to upgrade, you're going to see this. You're going to see a note in the upgrade process that it's switching that over. So for those of you that used to monitor spread under vSpread.conf, you're now going to be looking at the node table. So just be aware of that. So what are some of these benefits of the spread? One of the things is that our cloud environments, it's going to allow cloud environments to work more efficiently with spread. So that's really just a benefit if you're planning on moving to the cloud or have moved to the cloud. This is just going to work a little bit better. And then the other piece is that large clusters used to have difficulty kind of managing spread, and Elastic Cluster didn't work as well. So now Elastic Cluster will work with the spread, and large clusters also can employ the idea of fault groups, which is what we're going to talk about next. And fault groups' goal is to really improve the fault tolerance or your risk involved with setting up your nodes. So that's what we're going to talk about next. So the idea of fault groups is that fault groups distribute the data segments so the clusters can tolerate larger scale failures, such as a rack or a machine that's hosting multiple virtual machine nodes. So the idea here is that it's really mitigating your risk if a rack goes down or if however you set your cluster up. So fault groups are typically going to be used for larger clusters, but also smaller clusters who want to manage their risk of a rack going down or something like that can benefit from fault groups. So if you have a larger cluster, like 120 nodes or more, fault groups are going to be created automatically. So Vertica is going to do the fault groups for you if you have a cluster of 120 nodes or more. The fault groups will control the nodes and a subset of cluster nodes to manage the control of the messaging of spread. So again, if you're going to set up fault groups, or if Vertica is going to automatically set up fault groups, there's going to be spread is going to be managed with the idea that you could have sort of a main node and then non-spread nodes that are managed through that. Vertica places the nodes that share a control node into the same fault group. So again, the idea is that if it's an automatic fault group, Vertica is going to set this up for you. You also might want to set up your own fault groups. And if you did that, you could have different configurations. So you could set it up with nodes only. You could have other fault groups or other fault groups and nodes. So you can kind of set up your fault groups the way in one of these configurations. And then your cluster might have nodes in several different ways. So they could be located on the same rack. They could be co-located on the same rack or a group of racks. They could be on multiple racks or groups. They could be on multiple virtual machines that reside on a single VM host server, or they could be managed by a single network switch. So again, the idea of fault groups is to allow you to kind of spread things out and manage things in groups. And one of the things that you want to remember is that the data layout changes only after you do the rebalance. You run the rebalance cluster. So you want to make sure that if you're going to do this, you set up your groups prior to loading a significant amount of data. So if you're planning on setting up fault groups, you want to do this ahead of time. To monitor your fault groups, you're going to use v_catalog.faultgroups to observe the fault groups designations, and the vCatalog cluster layout to observe the relative positions of all the nodes in the cluster ring, as well as the different fault group details. So that's really what fault groups are and kind of how you'd set them up. Again, typically fault groups are going to be used for larger clusters, but if you're looking for some risk mitigation across racks, this also may be something that you want to set up. If it's something you want to set up, you definitely want to go into the documentation and read the details to really make some decisions about what makes sense for your setup. So I'm just going to check in with Ron. How are we doing in terms of questions? Do we have any interesting questions out there? I know this is a new topic for all Vertica users. So.
Yeah, so we're getting lots of questions around spread and large cluster. Just to clarify what these layers and what this means. Spread is our command and control layer for Vertica. So it's where, when we need to coordinate what nodes are in the cluster, how many nodes, if we need to stop and start a node, we send these sort of messages through spread. And all that's happening is the configuration of spread is being made much easier. The configuration of spread is happening automatically. It's happening through the database. The database server is handling the configuration of spread. So when we start the database, a new configuration file is written to all the nodes, and spread starts. So really nothing is changing in spread. It's just the configuration of spread. Spread is applicable to the conversation around large cluster, because large cluster means we have over 100 nodes, and there's a limitation in spread, which is a third-party open source tool which anybody can download and use. There's a limitation that that you cannot have greater than 100 or 128 nodes in a spread cluster. So what we're doing to work around that is have some nodes that will run spread, and we have some nodes that will subscribe to spread on other nodes. So some nodes will run spread, some nodes will subscribe to spread on other nodes. And this is how we're working around the limitation in spread. And if you have to do this, you're in quote-unquote large cluster. And this allows us to scale clusters to really any number of nodes.
Okay. And Ron, I guess just in sort of listening to the engineers talk about this, it's really the big difference with spread is how they're kind of building it into Vertica. That's really the big difference. But for the user, it's not going to make a huge difference unless you're working with a large cluster and need to start managing it in a little bit different way. Is that really accurate? Or
yeah, there'll be some slight changes for the database administrative personnel, but for a typical user of the database, this is all going to be transparent. The changes for the DBA mean it should just make configuration easier. We used to have a couple of different components which were responsible for configuring spread, and now we have just one component, so keeping spread in sync with admin tools is much simpler and straightforward.
This is Danielle, just jumping back for a logistical note. I've been trying to send out a message to everyone, but it doesn't appear to be working. What I'd like to say is that the sessions for tomorrow will be available at the same link that you used to log in today. So just click that around 11 a.m. Eastern Time tomorrow. And also the webinar will be recorded and available by the end of next week on vertica.com/webinars. Back to Kate. Thanks.
Okay, thanks. So hopefully, again, I think we wanted to introduce this topic of some of the new installations and some of the changes in spread just so that people are aware. But again, for most of you, you're probably not going to be seeing this or worrying about it. It's probably something that's just going to make things work a little better is really the idea. And I think that a lot of the topics we're going to cover today, that's probably going to be true. Some of this stuff is just going to be going on in the background, making things work better. There are specific job titles that will probably be affected by certain parts of it. So, again, we're going to get into some of this stuff. And, again, for some of you, you may never have to worry about the details of this. For some of you, it's just there to make your life a little bit easier.
Right, and I think fault groups falls under that category, particularly for database and system administration personnel. Fault groups it allows for correlated failures. So when we have many nodes spread out across multiple racks, we can lay out the data such that no two buddies will be on the same rack, so that we can experience an entire rack failing, and the database will continue to stay up and running. So that's the point of fault groups, to plan and account for correlated failures and to work around them.
Okay, so hopefully we've given you some good questions and some thoughts to think about in terms of how the new installation or upgrade process is going to work, but also some of the things you want to think about in terms of spread. If you're a large cluster, how you want to think about fault groups. What we're going to do now is we're actually going to move on to kind of our next topic, which is really just some load improvements. And when we're talking about load improvements, we're going to talk about some of the changes to the copy command. And we're going to look specifically at this concept of parallel parsing support. And we'll talk about the details of what that means. The other thing that we want to talk about is the idea that we have a native load balancer now. Vertica has its own native load balancer. We're going to talk about how that works and how you would set that up to work with it. The other thing that's coming with 7.0 is that we're going to have user-defined loads for Java. There's definitely some big improvements working with Java and Vertica, and we're going to talk about those. We'll see parts of those throughout probably all three webinars, I think, in different ways. But we're going to talk about a few of those in terms of the load process. And then the other improvement is that now you can create rejected record tables, which will allow you to query information about your rejected records. And so we're going to talk about that. We're going to talk about the commands you would use for that. So first we're going to start off with the copy changes. And really specifically, we're talking about the parallel parsing support. Now, the main goal of re-implementing copy was to improve managing its three main data phases. So the obtaining of the data, the filtering of the data, and the parsing of the data. And parallel parsing techniques allow you to improve the performance for large data loads. So if a file, and when we're talking about a large data load, we're talking about a file size that exceeds many hundreds of megabytes. So we're talking about large loads here. And the idea of parallel parsing activities is that, the parallel parsing activities allows the load to happen a little bit easier. So the idea is that it's going to improve the performance of large data loads. Again, this is one of those things that's going to happen in the background. So if you're doing a large load, Vertica is just going to do this for you. So you're going to find that some of your bulk loads are going to happen easier. One of the things you want to understand is that parallel parsing is just going to happen, but if you're doing a copy local, it's not going to work, and it's also not going to be applicable when loading data from HP Vertica supported drivers. So again, you want that this is something that's new. It's there to improve the copy command, but really it's going to happen with the copy command. Sorry. So before we move on, are there any questions about what we're talking about with parallel processing or anything you want to add to that, Ron?
The parallel processing should be pretty transparent. In the old days in Vertica, we used to have to break up large files into many small files, and we just don't have to do that anymore. Yeah. We can have multiple threads parsing a large file. So you just need to send one big file per node, and it should be just as fast. It should take up all the CPU, and it should just make ETL processes more simple and straightforward.
So again, just to kind of say, this is one of those things that's just going to happen, and it's just there to make Vertica run faster. It's not something that you're going in and changing how you run your copy command. It's just for larger loads, it's going to work. And again, we're talking about multiple megabyte loads.
Gigabytes.
Sorry, gigabytes. Sorry. At least I didn't say terabytes, right? Okay. The next thing we're going to talk about is loading Java. And what's new with loading Java is that you can have user-defined sources, user-defined filters, and user-defined parsers. So the user-defined source controls how the copy command obtains the data it loads into the database. The user-defined filter allows you to filter the data, and the parsers parses the data into tuples that are ready to be inserted into the table. So with this new feature, basically you're able to do this with Java. You used to be able to do this with other things, but now you can do it with Java. There are some requirements for doing this with Java. First of all, it must be written using the Java SDK and compiled into a shared library. You can have up to one source process, and this single process can obtain data from multiple sources. You can have 0 or more filters, meaning you don't have to have a filter. That's optional. And you can have up to one parser process. So those are kind of the things that you want to think about in terms of these user-defined loads with Java. But the benefit is that this is just a new feature that 7.0 is offering. Okay. Before we move on to the load balancer, I know Java is a big thing for a lot of different people. Are there any interesting questions or questions around Java that people want to ask at this point?
I don't think we're getting too many questions around Java yet. Lots of questions, lots of really different questions around copy statements. Again, the big change is that you shouldn't have to break up your files very much. Just one file per node, get it as big as possible, and send that over. You still have to break up the file somewhat. Again, one per node. And each node, the number of execution threads running on each node will determine the parallelism of the parsing in the copy statement. If you want to have the parsing run faster, assign more threads, execution threads to it.
Okay, great. So the next thing that we're going to talk about that's new with 7.0 is that we now have a native load balancer. So previously, you could bring in your own load balancer, but now Vertica is going to have its own load balancer. What you want to be aware of is that this feature is not on by default. And when you are setting it up, both the client and the server must have it enabled. And then to set this up, you would use these commands, the connection load balance equals 1, and select set load balance policy. Now, your policies would either be off, round robin, or random. Off means that you don't have a load balancer on, even if the client wants to do it. The round robin, it goes from one node to the next node to select the initiator node. So it's just going from one node to the next. And then random means that it's selecting the initiator node randomly. The benefits of using the native load balancer is that it's got better integration with Vertica, and your system no longer relies on a master node. So that's really what we're talking about with the native load balancer. So in terms of the load balancer, once you've set it up, this is the process the system would take to load information. First, the request comes in by the client. Then the request is sent to the load balancer master that then reviews the load balancer policy. And again, your policy could be round robin or random. So based on the policy, the load balancer determines what node will load the data. If that node is busy or down, then there's a failover policy. And that will come into play to determine which node will be chosen. Once the node is chosen, the load balancer disconnects from the master node and connects to the chosen node and starts the session. So that's really how the process would work with the load balancer. Oops, sorry. Sorry, I must have skipped. Sorry, I didn't mean to. I missed. Oh, sorry. Okay. Sorry, I was looking at a different screen. I apologize. So again, this is the process. This is the 5-step process. Again, the request is issued. The load balancer policy is reviewed. The load balancer policy determines the node, disconnects from the master node, and connects to the chosen node and starts the session. So that's how the load balancer works. And again, it's one of those things that's not on by default. You would have to set it up, and you definitely want to read the documentation in more detail. This is just giving you a brief overview of how it would work. Are there any questions out there on the load balancer at this point?
Lots of different ones. I'm not getting any sort of theme,
Okay.
But I mean, just to try to state it maybe in a different way, native load balancing is like a handshake process that happens between the client and the server. And basically, the client connects to the server and says, hey, which node should I go to? Server tells it which node, and then the client disconnects and connects to the node that it was told to go through. And then the rest of that session is with that node. So it's pretty transparent to the end user, anybody querying the database. It's the change that the DBA will have to make. The change is for both the client side and the server side, so there's configuration items that will need to change in your application and on the database server. And in terms of a comparison with other load balancing tools like an F5 or big IT product, it's better in the sense that it's more dynamic. So you don't have to query the database to find a node that is up. Basically, Vertica is already doing that in the handshake process. So other than that, it's very much the same. We've got a couple of algorithms, round robin and random, I think, are the two algorithms that determine which node you end up with.
Okay, great. There's a question of how would the load balancer work if the master is down. And
right, so I'm getting a couple. That's a good one to point out, Kate. Thank you. There's been a couple of questions about master nodes. There's no master nodes in Vertica. Almost all nodes are most customers are configured identically. So you can connect to any node, and you should connect to different nodes when you initiate sessions. And the reason for that is we want all nodes to be configured identically, and we want the load to be there's a little extra load that happens during the connection process on the initiator node. So we want to spread that out. So there's no master node in Vertica, and we just connect to any node.
Okay. So if the chosen node failed or is down, what happens in the session of the load balancer? That's when it goes to its policy on. It has a policy for that, right?
Right. So it's not going to send you to a node that's down when you first make your connection. If the node subsequently goes down, then you will have to restart your connection and connect back in, and you'll be routed to another node.
Yeah. Okay. All right, so the next thing that's really interesting that's been added is the rejected records as a table. So the idea here is that you used to go to your log files to look at rejected records. You now, in the copy command, can create a rejected table and basically send your rejected records to a table, which then allows you to just be able to query those records. So first of all, this just makes it easier because now you can query them and you can find a list of what the rejected data is and the exceptions in a table. And it's really just adding the command rejected data as table, and then you give it the name, and now you can find your rejected records. So I just thought this would be interesting to show you is if you created a rejected table, these are the columns that you would see. So again, just to point out, you've got your rejected data here, and then you've got your reason for your rejected data. So this is one example of a rejection table, and basically you're just from your SQL prompts, you can just or from whatever, you can basically query your rejected table. In this case, it's my rejection table, and you can look at the rejected data and also the reason for it. So this is that file that used to go into the log files. If you want, you can now create the rejected tables and be able to query the information. Okay. Before I go on to this next topic of CPU affinity, are there any questions about rejected table, or does that just seem pretty straightforward? Is there anything out there?
No, I'm not seeing much about rejected tables at this time.
Yeah, I think it's probably just a pretty straightforward piece. It's just a nice new tool. The next thing that we're going to talk about is CPU affinity. And this is a new feature that is part of Vertica that allows you to configure a user-defined resource pool that would use one or more specific CPU or percentage of available CPUs on the system. There are really basically two new settings in the resource pool. It's called the CPU affinity mode, which CPU affinity operates for this resource pool. And then the CPU affinity sets the CPUs in which the queries associated with this pool are executed. What I want to point out to you is that this is one of those parameters that you could change. You want to be really careful with this one because really defining CPUs and which CPUs certain resource pools are going to use, this can be a little bit dangerous if you're not thinking about a plan of why you're going to do this and how you're going to do this. So you definitely, for this, you want to read the documentation. If you have questions, call support, work with professional services. This is not something you just want to sort of play around with one day because it can really kind of mess up your system. It can be really useful for those customers that really need to work with this. That's why it's been added, but you do want to be careful with this one. Do you have anything else to add to that, Ron? Because I know you guys are a little bit nervous about it, but it is a parameter that people can see. So
I don't think we're nervous about it. I think we just know that there are sort of very specific circumstances in which CPU affinity will be helpful. It just gives us a little extra control in those circumstances. But for most customers, typical resource pool settings like memory size is going to be most applicable.
Okay, great. So again, this is just one of those that you probably should look at some other choices before you start thinking about CPU affinity. But for certain situations, it is useful. The next thing we're going to talk about is the SQL Server Integration. This is just to let you know that the Microsoft Connectivity Pack now supports Visual Studio 2010 and 2012, and SQL Server 2012. There are faster catalog browsing for third-party tools. There's an improved installer, improved interfaces, connectors, and bridges, and the metadata system table performance improvement. So really what we're just saying is we now support SQL Server 2012 as well as Visual Studio 2010 and 2012. So this is sort of your typical upgrade, moving from 6.12 or 6.13 to 7.0. We now support the new server level. Okay, we are going to now talk about, I'm referring to this as Query Optimizer improvements. There's actually a little, it's not all Query Optimizer, but basically we're going to talk a little bit about parallelism, partial group by, key value API, and approximate count distinct. The goal here is really things that are going to make your queries run faster. That's what we're talking about. The first two, parallelism and partial group by, these are things that are going on in the background. You want to be aware of them because now you're going to see some of this in your explain plans. You're going to see some of this difference. It's going to be noted, but you're not going to do anything to make it happen. So the idea is the first two are really things that the Query Optimizer are doing that makes your queries run faster, but you don't have to do anything special. It's just going to happen. Okay, so let's start with parallelism. Sorry. Okay. So when possible, Vertica is going to materialize columns early enough in a join to filter on both the inner and outer table so that it only now has to look at the required data that will be joined. So this is the idea. Is that, again, this is happening in the background. It's basically a more efficient way to do your join. So rather than joining a whole set and then doing the materialization to filter, now basically you're just doing the join on the data that you need. So it's really just making that join happen faster. Again, it's automatically applied. It's not something that you can make happen. You may see it in your explain plan. And what you want to understand is that this is done when there is when there's a hash join. So if you're doing a merge join, meaning your facts in your dimension table are sorted on those on the join keys, you're not going to see this. But if you're doing a hash join, the idea is it's just going to make it work better and more efficient. And let's see. I think that's it. So that is one of the new Query Optimizer features. Again, nothing you're doing, it's just happening. The other thing that's going to just happen is the partially sorted group by. Again, this is an optimization for queries for which the projection is sorted on a subset of aggregated columns. When processing the aggregate query on large data sets, the optimizer is automatically going to use partially sorted group by optimization to prevent or reduce the chance that the hash table will spill to disk. So again, the idea of this is to make your group by hashes work just a little more efficiently. The optimization has a significant impact when a query uses two or more distinct aggregate functions such as count or sum. And partially sorted group by optimization will not optimize queries where the data sets are small enough to fit into the main memory. So again, this is one of those things that's going to happen in the background. It's just going to make your queries run faster. There's nothing you can really do to make it happen, but you may see it in your explain plan. So you want to be aware that that's what this means. Anything else you want to add to these two?
Yeah, so for the partially sorted group by, the idea is that you do not need to have projections that are specific to all of the different possible aggregations. So basically, you can create a small set of projections that will apply to many different queries, and Database Designer is aware of this. So when you're developing your physical design, your projection design, this is when this is applicable. And so the idea is that super projections will handle most of the work, and we don't need lots of query-specific projections.
And we're going to talk about some of the improvements of the Database Designer when we get into our live demo of the Management Console on Thursday. And if you can just remind me of that, because we want to make sure we talk a little bit about that weighting piece that we're the Database Designer. But this is why one of the features that's allowing that to happen. This is just an example that you would see. So your partially sorted group by, just to point out, this is what you'd see in your explain plan. It actually says partially sorted keys. So if you see this now, it's not a mistake, it's not a problem, it's what's actually in the explain plan, and basically what it means is that partially sorted group by is working on your system. So that's a good thing. And it's making your queries run more efficiently. Okay. The next thing that we are going to talk about is, the key value API. The idea here is that Vertica is good at a few big queries, but it's not always been so good at many small queries. So with 7.0, what HP has introduced is the JDBC key value API, which is allowing you to quickly query data when a single or only a few rows are being returned and the data exists on a single node. So the idea is that it's the feature is ideal for high-volume, short requests that return small numbers of results. So the way it would work, and this is sort of what the diagram is trying to show you, is to route the query directly to the node that has the data. So you would set up the segmentation client side, on the client side, tell the driver explicitly what the segmentation key is. And so since we know that only the node, that has the data, the query optimizer doesn't have to do the global planning and the execution. So it'll just scale, so it'll just work a little bit faster and be more optimal. And as your cluster grows, it's going to scale to that. So the idea is that only the initiator does the work. The other nodes are unaffected. And this makes it a little bit more efficient because, of course, you're now not having to wait for the other nodes during the planning and the moving of data and so forth. So the idea of this, again, is that this is one of those things that you would have to plan for. But the idea is that rather than going through this whole process of doing the plan, the results, going back and forth between the nodes, you're actually setting up your segmentation, and then you know where the data is. So it's just a much more efficient process for these small, short queries.
Right, so I can add a little more color. I mean, what's happening is, this is for JDBC driver only, by the way. I don't know if we mentioned that, but this is key value API is only available for JDBC. And what's happening is the driver is caching the projection design, so it knows which nodes handle which rows, essentially. And when you have to build a query programmatically, so you apply a predicate, and you need to apply the predicate that's used in the predicate. You need to have a column that's used in the segmentation. All the columns used in the segmentation. And when you do that, the cache projection design you can look that up in the projection design and figure out which exact node that the rows you'll be interested reside on. So it reduces a lot of work that needs to happen. We eliminate all the other nodes as possible candidates to answer this query, and they don't need to be accessed.
Okay, great. Thank you. This next feature is really not Query Optimizer specific, not JTBC specific. It's really just a new function, and it's called Approximate Count Distinct. And this is for those people that are doing count distincts in their queries. And the idea is that if instead of using count distinct, you use approximate count distinct. What it's doing is it's basically going to do it faster if you are doing large pieces of data. So really this would be a replacement for count distinct. And what it's doing is it's using some algorithms, and you can set the accuracy to be -1%. So it's 97% of the time accurate. So you're setting up that percentage of plus or minus what your deviation is. And you can get this accuracy and get counting available. Now, what you also want to remember is that you can also, the benefit of this is not just that it does count distinct faster, which is obviously a better thing, but it also allows you to roll up the results. So you can have the roll-up of hours into days, into months, and so forth. So as you're using this count distinct, you can actually roll it up or expand it out as you need it. And the distinct values do not need to exist on each node. The idea is it's going to use memory more efficiently and return the result. So it's just a more efficient way of doing count distinct. And what it's really doing is, I mean, when the engineers described it, I was thinking, okay, so they're using a form of statistics to make count work better. It's really what it's doing. So if you want to add to that a little bit.
Not much. It's based on the hyperlog algorithm. So it's there's papers that we can send out. I mean, it's the white paper for computing the number of distinct values in a data set and doing that very quickly with a low amount of memory. So the idea here is that this will be really helpful if you don't need to know the exact count. You just need ballpark numbers. You can apply an error percentage so that you know how much error you're willing to tolerate. And it can be really helpful if there's multiple count distincts in a single query. So your multiple distinct aggregates.
And, again, when we were looking at this, when the engineers were first presenting this to us, I just looked at it and thought, this is really cool stuff because it's really much faster. So if you really, if you just do one single one and look at the difference, it's really so much faster. And then, if you've got a query with a lot of count distincts in it, it really can speed up your processing and make it more efficient. So
the roll-up idea is that we don't need to double count if we have to. If we're grouping by columns A, B, C, we can do that once, and we can use the same intermediate calculations, same intermediate data to also do aggregates for A and B, columns A and B.
Yeah. Okay. So that pretty much takes us through the topics that we are going to cover today. I know there's some more questions out there, so we are going to get to those. But just to do a quick review of what was talked about, we started off with some installation improvements, and again, I highly recommend going through the documentation and making sure you're really clear about, especially for those that have done installations before but are planning on upgrading, definitely read the documentation and get a look at this. I think you're going to find that the improvements for linking to the docs and the notations are really going to be great. In terms of load improvements, again, we've got improvements in the copy command. We've got improvements with spread that, again, for most users is not going to be a big deal for DBAs. It's just going to help you make your life a little bit easier in terms of configuration. The same with fault groups. Fault groups are out there to make life a little bit easier for the DBAs, but, again, it's more about configuring and setting up your system, looking at kind of your risk mitigation in terms of if your racks go down and that sort of thing. In terms of SQL Server improvements, really we're just making ourselves Vertica available for SQL Server 2012, sort of your typical upgrade features. And for query optimizers, we talked about the parallelism and the partial group bys. These are things that are going to go on in the background. not something that you necessarily have to think about, but really it's just there to make your queries run more efficiently, allow you to have fewer query-specific projections. But you will see some of these notations in your explain plan, so you want to be aware that they're out there. And then we talked about the approximate count distinct, which is our new function that just makes counting a little bit faster, which is a great thing. And the when's the last time we talked about the API? Sorry, that's out there for the JDBCs.
Just getting lots of questions about where the documentation is and or where we can get the software. So visit my.vertica.com. If you don't already have an account there, create one, please, and you can download if you're not a Vertica customer, you can download the Community Edition version of the software and the documentation. The documentation is the same. And if you are a customer, hopefully you already have an account there, but that's where you can get the software and the documentation.
And the online documentation is available currently for 7.0. It's right on the website, so it's and it's pretty clear, easy to use.
Are we going to make these slides available?
The recording will be available by the end of next week for all 3 of these webinars that we'll be running. Just a reminder, we've had a few questions come in. You can use the same link to join us tomorrow at 11 a.m. Eastern Time. And Kate will be back on to tell us about semi-structured data exploration and what new features you can look forward to in Vertica 7. So we look forward to all of your participation.
Okay, so let's just, we're looking at some of the questions that are coming up. Let's see. Will load improvements help develop an environment where large source files are reading? Okay. I'm not sure what. Let's see. So we're just going to go. It takes me a little time to read some of this. So, what is the query for the plan showed? I don't remember. Sorry. Let me just go back to that slide if I can remember what the query was for the plan shown. I don't remember what plan I was looking at. I do apologize. I was working on some test data, but I don't remember the plan. Any ideas on that? No. Sorry, I don't actually have the query off the top of my head. I wrote that one a while ago. Okay, so do you want to look at 110?
Sure.
Oh, 110. So one of the questions is, how is the row number established if there are more threads processing a single load file? Where is the exception table? So there's not an exception table. If you're creating a rejected table, the exceptions will be in that, or it's in the log files.
Yeah, that's a good question. So in terms of the rejected table data, there's not 2 separate tables. There's one table, and that's where you'll have your rejections and exceptions. So as Kate pointed out, there's columns for the reason why the data was rejected, which is the exception. And really what's happening here is this is even if you specify a rejected table, the file is still written to the server. So basically, it's very similar to an external table on top of these text files. So if your ETL process uses these text files, you can still continue to use them and use the rejected table to query for your rejects and exceptions.
Okay. And did we get to, I noticed there was an interesting question on 113, but I lost it. Sorry. Yeah. Can you reload the data from the rejected table to the target table if you fix the rejections, correct?
Absolutely. You would have to, again, it's very similar to an external table, so you can't update that data, but you can run a select statement, and you now have access to the data that was rejected.
Yeah. Okay, and then there's a question out there about finding information on getting started with Vertica. There are some, if you go to the Vertica.com and you go to training, there are some online trainings, and then of course we do have public classes, our introduction class is now called Essentials, and also there are some online versions of that class. And in terms of the documentation, again, under Vertica.com, you can go to documentation, and there's a link to the 7.0 documents that's online. For those of you that like PDF files, you can also download a PDF version of all the documentation. So either way, whichever works for you. So let's look at some other questions. Let's see. With all these new improvements with copy, do you think we can have a performance improvement using ODBC drivers? For example, using Informatica.
So I do know that there is work happening around the Informatica connector. I'm not sure of the status on that. We could get product management to give us some more information about that.
But that's right. That's something that's in process, right? I don't understand 162 because I can't read it. It says, have the RUDX source that is tarball? Is that table, maybe? No, tarball.
I'm not sure what that question is getting at.
Okay. So whoever put in has the RUDX source tarball, but enhanced, I think you need to maybe re-ask your question. We're not clear on that. Can you show the SQL slide again? Absolutely. I can certainly do that. What is the range of performance improvement in terms of percentage we can expect from parallel process parsing? I don't know if we have. Do we have a?
I would have to refer to the documentation to see if there's any benchmarks. Basically, the parsing is traditionally been the slowest part of the load operations. So I would expect that we could have significant improvements with files of any size, of significant size.
Yeah, but I'm not sure. I'm not sure the documentation's actually gotten any benchmarking there yet. Okay, with the key value API, what happens if the node where the data resides goes down? Well, then it would have to go back up, right?
Well, if there's a buddy projection, which there should be, you can use the buddy.
Okay, good point. Is there any plans to make vertical analytic database enterprise data warehouse ready?
I'm not sure what that question is getting at. I mean, we have customers using Vertica as an enterprise data warehouse. So if there's specific features or functions which are needed, we'd be interested to know what those are.
Yeah. Any improvements on R within Vertica for release 7? I don't remember any R improvements. Do you?
So R is a statistical processing platform, and we already integrate with it quite well. We haven't made changes to the external source, but I don't think there's been additional changes in terms of integration.
No, I don't remember that. Okay. Will there be SQL Server 2014 support? Not with 7.0, but will it? I assume that it will come with a future version. Okay. I think that we have gone through most of the questions. Ron, you can keep looking, but I think that we are pretty much at the end of this session. Thank you all for attending. We look forward to listening to your questions tomorrow and the next day. Again, tomorrow we're going to be doing semi-structured data. And then on Thursday, we are going to be doing a live demo of the new Management Console, which will also allow you to see the new Database Designer. So for those of you that are interested, those are the topics that are coming up over the next 2 days. And we will be going over flex tables tomorrow. That is one of the questions up there. So that is the semi-structured data. So thanks very much, and everybody have a great afternoon.